Welcome to another new video of interesting math problem on our channel Math Solutions for You. Please do like, share, comment, and don't forget to subscribe to our channel. In an isosceles triangle, two of the unequal angles in degrees are equal to 4x and 5y respectively. If x and y are both integer multiples of 10, what is the value of x plus y? So we are given an isosceles triangle, and we know that in an isosceles triangle, two of the angles of the triangle are equal. But the angles that are indicated in the figure as 4x and 5y, so those are the unequal angles. So that means that the third angle of this triangle should be equal to one of these two angles. However, we are not given which one of these 4x and 5y would be equal to the third angle. So we simply start with an assumption that the third angle is equal to 4x. So here we have an isosceles triangle. Two of the angles are equal, each being equal to 4x, and the third angle is 5y. Now these are still the angles for triangle, so they should sum up to be 180 degrees, and then we basically end up with this equation 8x plus 5y equal to 180. Now we utilize the information that's given that x and y are multiples of 10. So we can let x equal to 10m and y equal to 10n, where m and n are positive non-zero integers. And if we substitute these values of x and m in the equation, we get 8 multiplied by 10m plus 5 multiplied by 10n equal to 180. Now if we divide both sides by 10, we end up with this. 8m plus 5n is equal to 18. Now we know that m and n will have to be positive non-zero integers. So whenever this is the case and we have an equation in two variables, in this case m and n, and we know that m and n are constrained to be positive non-zero integers, we do a trial and run approach where we start with the variable that has got the larger coefficient. In this case, it's the variable m, and we start with what the lowest possible value of m could be, which is, in this case, 1. So if we substitute m equal to 1, we get 8 plus 5n equal to 18, and we solve for the other variable n. This is a simple equation to solve, and n comes to be equal to 2. So we have one set of integer solutions, m equal to 1 and n equal to 2, which seem to be working pretty well. Next higher value of m will be m equal to 2, and for this the equation becomes 16 plus 5n equal to 18. We just substitute m equal to 2 in the equation, 8m plus 5n equal to 18, so that's why we get 16 plus 5n equal to 18, and then we solve for n, and in this case we have a problem because n doesn't come out to be an integer, it comes out to be a fraction. So clearly this is not permissible. Now do we need to test still higher values of m? Well, for m equal to 3, on the left hand side we have 8m, which becomes 24, which is clearly greater than what we have on the right hand side of the equation, which is 18. So for m equal to 3 or higher values than 3, n will have to be negative, and we know that's not possible because both m and n will have to be positive integer variables. So the only set of values of m and n which seem to be working in this case is m equal to 1 and n equal to 2. So what does that make x plus y? So we know x equal to 10m and y equal to 10n. So if we sum up x plus y, we get 10m plus 10n, and we can take 10 as common. So within parentheses, we end up with m plus n. And in this case, m equal to 1 and n equal to 2. So that makes m plus n equal to 3. And we have 10 multiplied by 3 equal to 30. So x plus y is 30. So it seems like a solution to this will be x plus y equal to 30 degrees. And since this is a multiple choice question, it's okay to leave this here and just pick the answer of 30 degrees. That's an option B. But strictly speaking, this problem is still not over yet, because we have assumed that the two equal angles are each equal to 4x. But nothing in the problem that was provided, nothing given in the problem told us that that's the only possibility. So we have to consider, for the sake of completeness, the other possibility where instead of the two equal angles being 4x, we have the two equal angles being 5y. So in this case, once again, we proceed in a similar fashion. So we have 4x plus 5y equal to 180. And we end up with this equation 4x plus 10y equal to 180. If we divide both sides of the equation by 2, we get 2x plus 5y is equal to 90. And now we can substitute x equal to 10m and y equal to 10n, because remember, x and y still got to be integer multiples of 10. So we substitute this and we get this 2 multiplied by 10m plus 5 multiplied by 10n is equal to 90. And if we divide both sides of this equation by 10, we get 2m plus 5n is equal to 9. So we know that m and n will have to be positive integer variables. So we start this time, since n has got the higher coefficient, we start with the lowest possible value that n can take, which is n equal to 1. And for this value of n, the equation becomes 2m plus 5 equal to 9. We solve for the value of m, and that comes out to be 2. So n equal to 1 and m equal to 2 seems to be working in this case. Now, do we need to test higher values of n? Well, for n equal to 2, on the left-hand side, we have 5n. So 5n becomes 10, and that becomes greater than the right-hand side, which is 9. So for n equal to 2 or higher values of n greater than 2, m will have to be negative, and we know that that's not permissible because m has to be a positive integer. So these two are pretty much the only set of values that m and n can take under this scenario. And so what does this make x plus y? So x plus y, remember, it's equal to 10 multiplied by m plus n, and in this case m plus n is 2 plus 1, 3. So if we substitute those values of m and n, we still get 10 multiplied by 2 plus 1, which comes to 30. So no matter what the equal angles are, whether they are each equal to 4x or each equal to 5y, x plus y in each case turns out to be of the same value, 30. So the correct answer in this case will be option B, 30.